Hello again. I found this interesting. I just got it to run, and the thing was that I wanted to do all my serial transmissions at one time. I was like with this guy here. There's a video on this system I've been playing with for a while, and this system receives a byte from this guy over here. And then it sends a response. It sends processing to this guy via 32. Here's the little cable I had. While I was making it, it works fine, and it's video on YouTube. You can find all my videos if you just search for LJAY0778. And it's there, but the thing I saw was that I would miss some characters if the timing wasn't right, because I was getting a byte, processing it, sending to the LCD display, coming back, getting another byte, and so forth. So I had to get the timing there and squeeze in delays to get it just perfect. So I said, why don't I build a buffer and just get this entire transmission, in a snap, and then I can pick it off a RAM with pointers and send it to my display. So I did. It wasn't so simple, it still isn't. I have to integrate this little piece I just got working into the other ones, but that's what I did. It worked. I built it into the big programs, and it worked like once. But there was timing issues, and I couldn't get the right thing, whatever. So I always pull out the little block and build the little building block, then put it back in the main program if it ain't working. So I want to show you. It is on, and what this thing is doing, this little data buffer, is I'm going to enter ASCII letters into the RAM. It's going to be coming RS-232, and then I'm going to press the button and have them play back. So it is symbolic of this sending the data. So I'm just going to press keys, and we shall see on the LEDs here. These are just random keys I'm pressing. I don't know what the number is. Actually, to be truthful, I might have some wires crossed on the port to the LEDs. I just kind of threw this little keyboard on here to use the LEDs, because this one didn't have LEDs. So I'm just entering letters, symbols, whatever. And then, because it is an ASCII keyboard, I'm using the equal sign, because I couldn't get a null from the keyboard because it's all ASCII numbers. 0 is like 30. So I said an equal sign is way out of the way, and I should be able to see it. So I'm going to press the equal sign on the keyboard, and it should play it all back for us, and then come back and accept new digits. So let's press it. There we go. It's doing it all on its own. I'm not playing with the keyboard. Now here's my other hand, kind of. So actually what it's doing is getting the bytes we inputted or symbolically received from the other system. Now it's ready for more bytes. So I'm just going to input like 3, 1, 2, 3. Press the equal sign again, and it should just give us those 3. 1, 2, 3. Or 4, 1, 2, 3, 4, 5, 6. Press the equal sign, and it stops. Or we can again enter a whole bunch more or whatever, and equal sign, and it should say Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. that's about it. I'm pretty happy it's working. Now I can receive data, put it in the buffer and get it, and do with it, do with it whatever I want. When I want, I can just store it, move it elsewhere. Whatever. So this one, for some reason, I just wanted to move one byte to one chip and have the chip respond. So this thing is kind of like growing. It's growing all by itself. I don't know what else. Next, I think I just want to put a keyboard with a interrupt instead of wasting so much memory space. To use so much scanning and what have you. Just hit it on the interrupt, get the data, send it, let go of all them lines. It can be used for something else. Hope you enjoyed the video. I think I'm going to put the software. It is in assembly along with this presentation here. So it was quite fun, playing with memory. Over and out. Bye.